This is the homework for lesson number 4 for the GPS latitude and longitude separation, for for parsing out the bits and pieces of that word, GPS word. Okay, what I did was I added the display information, the libraries for the display. In this particular case, we needed latitude. So I defined latitude equals blank and longitude equals blanket and GPS time equals blank and number of satellites is blank. Actually, I'm not using time, but I just put it in there. Let's take it out. Don't need it. Sometimes I put stuff in I don't need. I'll probably need to do it later. Okay, well, I did latitude, longitude, and number of satellites. I think that's what Paul asked us to do. Okay, then I defined the object for the display in these 3 lines. I initialize the display. I say what size the display is, and then I define the I squared C parameters. Okay, now we get down into here. I've got this thing set up as here I've got a try and while true, and it's the same thing we did with the first program we did. And in this case, I just took out all that other stuff and put in get position data, and I got 2 functions, one called get position data and the other function called convert to degree data to degree. Okay, so what I'm doing here is get into this guy. I put in the global things for the latitude to longitude, GPS time, number of sats, timeout, and the fixed state, I should say. And then timeout time equals time.time plus 10. So I'm putting in about 10 seconds for get the lock. And then here, I define buffer up here as a 255, GPS bit array 255. And then down here, I take and I say buffer equals the string, the GPS dot read line. I didn't want to read individual bits. I said I wanted to read the whole line. And then we put a little bit of delay in there, give it time to do it. Then here, the parts of the line are going to be GPS buffer dot split. I split it on the comma. And in this particular case here, to get things started, I look for the bits, the GPGGA has to equal GPGGA and the length of the parts equals 15, because it might be more, or you might have a bunch of spare parts hanging off the end of that thing and screw everything up. Okay, down here I said latitude equals convert degree part 2, which part 2 is the degree. And the longitude is convert the degrees to part 4. So 2 is the latitude, 4 is the part for the longitude. And then if the part's 3, which is the north and south, if it's south, we change it from latitude to minus latitude. And this is the only way I could figure out to do it. I'm sure there's a better way, but that was the only way I could find that would work. Because every time I put latitude equals minus latitude, it would bomb. So you can't do that because it's a string. So I found this way online, so I started going in that way. Then part number 5 is the W for west, or if it's west, it'll be also negative. Otherwise, they're positive. Then the number of satellites equals part 7. And if you get all through this stuff, fix is true. And if then it breaks out of it, and then we have a time equals greater than timeout. Timeout's true, and then break, and then we start this baloney all over again. Now down here, convert to raw degree, because you can't just get the degrees based on what you're reading, because there's positions you have to take into account. You got the float. This takes the raw A float equals raw floats, and then the first digits equals degrees divided by 100. And then the next two digits is raw equals minus float, two digits, first digit, and 100. And then you convert those digits by dividing them by 60. And then we just do a little formatting thing here and make sure you get six decimal places. And then we return the converted degrees. In other words, if you get what you get on this guy, it comes back with actual 32.341595 or whatever. Get down here, first thing I do is call up get position data, GPS. Then I've set up my displays, and the display says latitude. Then I display the actual latitude. This is my X and my Y position on the little display. And then your longitude equals the same thing, except they're a little further down so they don't overwrite each other. And then we've got the number of satellites equals number of satellites, and then I put that a little bit further down. And then I say show to show the display. Otherwise, it just sits there. Anyhow, you've got, then here I went ahead and put in print information for the screen here if you just want to look at the computer. And here is the same stuff that we did before to clean up the UART. All right, let me do a Control C. I'll clean up the UART. And then we'll start it again. Okay, now let's start it again. And you can see it's got the latitude, it's got the longitude. Oh, I spelled longitude wrong. Try D. I left out the D. All right. Nobody said I could spell. I mean, what can you say? I've just spelled Tucson, where I live. Anyhow, here we go. I set that up. Let me rerun that because I got to stop it right. Control C to clean up the thing so when I run it, it doesn't bomb. Okay, now it's spelled right, longitude. I didn't notice that. I probably spelled satellites wrong too. Satellites? I'm not sure. Anyhow, there's my homework, Paul. Misspelling included. And I appreciate you doing these videos and looking forward to Thursday. Bye.